All right, hey, I'm going to pre-warn you guys. You're getting recorded today as far as the lesson, because I'm not going to be able to see my fifth period today, so just know that, all right? So, let's go ahead and get our homework out from last night. It came from page 44 through 46, no, 45 and 46. I think it may have all just been on page 45, though, right? But anyways, y'all had a handful of questions that you needed to graph and find the intersection, and specifically find the what value of the intersection, the x value, right? So get that out. I'm going to put it up, and then we're going to check to see who did it, who didn't do it, or go through any questions that you have, and then we'll start something today that is kind of new, similar to yesterday. Has anybody seen cases today? Is that his method?
You went to that. Some walk out of that.
Okay. Did y'all do it?
There it is.
Did y'all do your homework? Yeah. Good. All right. So let's check the answers, and then I'll come around. The question was asked: did you have to put x equals? And it's not absolutely a necessity. If you did, that's fine. But if you just wrote the answers, that's fine too. As long as you never round to a whole number. Never round to whole numbers. We don't like that. Uh-oh. You? Good. Good. Thank you. So that writing. Thank you. Okay, you good? Hey, if that's what's in your way, feel free to do it.
Okay.
This is I fixed that in my printer yesterday. All right, so couple things real quickly. Rounding. Y'all with me? Blake, you with me?
Yes, sir.
When it comes to rounding, my big thing is never round to a whole number. Okay? If it's a decimal, you need to have the decimal. So very rare will you have an answer that's a decimal that you can round up. But like if it's like 1.998, that's fine. But most of the time, if it's a decimal, I want to at least have one or two decimals at the minimum. But I don't get hung up on how many. Okay, it's not like I say, oh, you always have to give me two decimals, or you have to always give me three decimals. Okay, your call. For example, like on 23, I felt like the one value, the negative 0.55, I just thought it looked better as two decimals. But the other one, I did 1.8 because I just thought it was better as one decimal. So I'm not going to get too hung up on how many decimals. Just please don't what? Round to whole numbers. Okay? Don't round 1.8 up to 2 because that's not right. All right? So just make sure you follow that rule. Okay? And I promise you, I will see that you did it right. If you're rounding differently than me, that's not a big issue. okay? You wouldn't imagine how many times I'll say this, and later somebody will have gotten negative 0.9 on 24, and they say, well, you got negative 0.87. Did I do it wrong? No, just rounded it wrong. So just know I don't get too worked up over that, okay? Any questions over any of those problems that you had to do last night? Okay, so as we move into what we're doing today, and again, I want to remind you guys, every day, at some point, I try to update Google Classroom with what we did during class, okay? Most of the time, I do it before the day is over. Today, since I had a student in 5th period, or I'm not going to be able to be with my students in 5th period, I'm going to add a video to Google Classroom today, and therefore I haven't put all the stuff in there. But when I do, you'll always get your note sheet and then the assignment, okay? If it's from the book, it'll just say page number, blah, 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 numbers, blah, blah, blah. But if it's a worksheet, it'll be uploaded too. So don't forget, if you're at home, that you can always find your assignments on Google Classroom at some point during that day. Usually at the beginning, but sometimes I'll hold off for a little bit, okay? So let me give you guys a little heads up before we start today on what the difference is between yesterday and today. Yesterday, if you guys recall, we were dealing with one equation, right? A single equation. Now, that single equation had some stuff on the left side of equals, and it had some stuff on the right side of the equals. But it was a single equation, and that's why when we found that intersection, we only looked at which value? X. We only looked at X, okay? Only. And Lily, I need to see your assignment. We only looked at X. Now, today, we're not talking about a single equation. We're talking about what we call a system of equations or multiple equations. So when we're dealing with multiple equations, when we find that intersection, we're not just talking about X, we're talking about both X and Y. Okay? Now listen, if I were to go to a calculator and look at it, it's going to look identical to what it looked like yesterday. The difference is, yesterday was a single equation, so we only looked at the X value of our intersection. Today is multiple equations, and that's why our solutions include both X and Y. Does everybody understand that? Yes. Okay, we are going to do it algebraically today with math. But you can always use your calculator to do what? Check your work. And I encourage that, okay? To use your calculator to check your work. Did I see your homework from yesterday?
Yesterday. Wait, no, yes, I have it. I'm doing hard. I ran out of notebook paper. I'm getting more today.
Hey, we people who use Galaxy Note 8s or above, we are the most sophisticated people in the planet. And therefore, I will gladly accept an assignment that is on S Note. So, anyways, all right. I will take jabs at apples as much as possible. So, it's like Vanderbilt fans taking jabs at us Tennessee/Kentucky fans, which that doesn't make sense to people, but that is my reality. So, anyways.
Considering the fact that half the time he still loses.
No, not baseball. Studs in baseball. Right?
Yes, they are.
So, anyways, plus they're one of the nice teams in the SEC, which we're okay with them. All right, now today what we're doing is we're solving very simple equations, but we're starting by talking about how to solve systems of equations algebraically with math. Okay, so it's going to be similar to what we did yesterday, but we're going to do it with math. You are welcome to check your work with your calculator. I encourage it, but we are going to talk about math. So here's how we have to start. We've got to make sure with our multiple equations that they are set equal to y. So the first thing we got to look at is y alone? If not, let's solve the equation for y. Okay? That's pretty easy, right? Now, I want you guys to use your brains for a second. If I've got two equations and they are both equal to y, what has to be true? They're equal to each other, right? If they're both equal to y, then they have to equal each other. That makes sense, doesn't it? Now think about it. If they equal each other, what can we do with them? We can set them equal to each other. And if we set them equal to each other, we no longer have a y. We only have what? We only have x. And what can we do if we only have x? We can solve for x. But because this is a system of equations, we don't just want x. We want x and y. So therefore, we plug the x value back into a simplified equation, and then we can solve for y. And our solution will be an ordered pair. Okay? It'll be an ordered pair. Some of our equations that we'll do in the future, and a couple of them that you'll have to graph in a minute on your assignment, it'll actually be multiple ordered pairs. Okay? But I hope that you understand the difference that I tried to start this lesson off with, and that is this. When it was a single equation, all we cared about was the x value of our intersection. But when it's multiple equations, we got to care about both x and y. Okay? Y'all with me? So that's what we're doing today. Multiple equations. You got to focus on an x and a y. So look at A. And what did they already do for us? They already got them equal to y, don't they? That's already taken care of. So step 1 is done. So what does step 2 say? If they're both equal to y, they have to equal each other. So what I do essentially is I ignore this, and I take what is both equal to y, and I set them equal to each other. So 9x minus 5 equals x plus 3. Now, doesn't this look like the graphs that we did yesterday? It does, doesn't it? It looks almost identical, right? So at this point, that's what you could go graph in your calculator if we were solving this by graphing. The only difference is you're going to actually state the x and the y value because this was 2 equations, not just 1. So let's do it algebraically. Can we solve this? This is something we've done, right? We know that we need to move the x's together, right? I always like to move the smaller one. Which one's my smaller x value? So I'm going to move it by subtracting it, right? It's positive, I subtract it. What's 9x minus x? So 8x minus 5 will equal 3. Everybody see that move? I'm not showing the process, I'm just showing the steps. Now what? Add 5. 3 plus 5 is? So 8x equals 8. And then divide by 8 and x equals 1. Now, what do I do last? You can go back to one of your simplified equations, and you can just plug that new value of x that we now know into it. So which equation looks easier to y'all? The bottom one? Yeah, I agree. It's a little simpler. So let's go to that bottom one, and let's go, okay, y then must equal x, 1, plus 3, which is 4. So my solution is what? 1, 4. Why did you put the 1 first? Because we found it first? Because it's x, right? We always put x first, y second. So we put 1, 4 is our solution. And that's it. That's how you solve this algebraically, okay? Now, did anybody happen to go to their calculator, type it in? Anybody happen to go look at where they intersected? Nobody? I guarantee if you did, they would have intersected at 1, 4. Okay, guaranteed. Because we just did the same thing we did yesterday, but because it was two equations, we needed to have the x and the y. Okay? When two equations intersect, they're going to intersect at an ordered pair. All right? Okay, so V. What's the difference between that problem that we just did and V? Yeah, we don't have y. We don't have y alone, right? So let's take this first one. This y plus 4x equals x plus 6. And you don't have to rewrite it. I'm just rewriting it so we can start right here. How do I get y alone? We subtract 4x, right? We subtract 4x from x because we moved it past equal. So y will equal, what is x minus 4x? What kind of 3? So negative 3x plus 6. Now is y alone on that one?
Yes.
Okay, that one's done. I can move to the other one. So we got x minus y equals negative 2. Yes. What are you going to do first?
You're going to subtract x.
Subtract the x from the negative 2.
Yes.
So these will cancel, and negative y will equal negative 2 minus x. Now, is y alone?
No, you have to divide by negative 1.
Yeah, remember, if there's a negative in front, it's like having a negative 1 attached, right? So how do we get rid of that negative 1? We divide by negative 1. So these will cancel, and y will finally be alone. Now, how do we deal with that negative 1?
Y equals 2 plus x.
Yeah, we just distribute it, okay? What is negative 2 divided by negative 1? Well, that's positive 2. And what is negative x divided by negative 1? Well, that's plus x. So it becomes y equals 2 plus x. So now, do we have our y's alone?
Yeah.
So if they both equal y, then they both, finish that up for me. If they both equal y, then they both equal each other. So therefore, what am I going to write?
Negative 3x plus 6 equals 2 plus x.
All right, negative 3x plus 6 equals 2 plus x. If they both equal y, they both equal each other. So I ignore the y's, and I basically am substituting these values in for y, and they're set equal to each other. So what do I need to do to solve this one? Distribute?
Alright, move the x over.
Yeah, let's move the x over. Which one? You want to move the negative 3x or the plus x?
Plus x.
You want to move that? That's fine. We will. Let's subtract x. What is negative 3x minus x?
4x.
What kind of 4x?
Negative 4x.
So negative 4x plus 6 equals 2. Now what?
Subtract 6.
Subtract 6. Negative 4x will now equal, what's 2 minus 6?
Negative 4.
Negative 4. And then last we would have had divide by negative 4. So what's negative 4 divided by negative 4? 1. Now maybe I solved that a little differently than you did. But in the end, don't we both get 1? And that's fine. That's all that matters. X equals 1. So what's my last step? Which one do y'all like better? The blue one or the red one? Yeah, that red one right there. Just the 2 plus x. That's the best simplified one, isn't it? So I'm just going to go, okay, y must equal 2 plus, what is x? What did we just solve x to be?
1.
So 2 plus 1 equals. So therefore, my solution, because I need to put it in the correct order, my solution is 1, 3. 1, 3. Huh? Did I have a question? I heard something. No?
I messed up on my fault, but I know what I did. So.
Good. It's good to find your own mistakes sometimes. It's a good way to learn. All right, so pretty easy, right? No, Blake? What part?
I got 2 with x. X equals 2.
So, did you set these equal?
Yeah.
What was the first move you made?
I did negative 3x plus 6 equals negative 2 plus 4. I moved to 3x.
So you had negative 2 plus x?
Yeah.
Okay, that's where the mistake was made. Remember, the original, when we moved that x over, was subtracting it. When I divided by negative, it had to affect both of these. So that negative 2 divided by negative 1 should have been a positive. So that's where it got messed up, that positive 2, okay? Because that means you would have added 2 when you should have subtracted 2. And that makes a difference of 4, which when you divide a difference of 4 by 4, that's an extra one. That's why you got 2 instead of 1. Does that make sense? So just that little thing right there. All right? Anybody else have a question? All right, not too bad, right? Okay, so let's go down to this one, C. Let's start with x minus y equals negative 1. Hey, can I show y'all a way I like to do this to not work with negatives? How can I get rid of the negative on the y? Can't I add y? And think about this. Aren't I trying to get y alone? So what can I do at the same time as adding the y to get rid of that negative 1? I can add the 1 back to the other side. It's almost like they flip-flop positions. Y'all see what I'm saying? So I did it in one step, but what is left on the left side when these cancel? X plus 1. And what's left on the right side when these cancel? So y is alone. And I was able to do that in one step. That's a lot like if we went back up here to this one. I could have done this one that same way. And it would have been a little easier. But again, I like to do it the way that whoever it is that's helping me, because I want you to know it always works if you follow your math correctly. But there are some shortcuts that you can maybe make that will make it a little easier on yourself. So there's that one. All right, next, let's look at the 2x plus y equals 4. And this one I wouldn't say has as many options, because isn't y already positive? So let's just move the 2x. How? Let's move the 2x. How? Subtract it, right? So we're going to be left with 4 minus 2x. 4 minus 2x. So, what did we just accomplish? They're both now equal to y, so they're equal to each other, right? So let's take them and set them equal to each other. So we've got x plus 1 equals 4 minus 2x. Okay? Let's focus in right there. What am I going to move? Tyler, what would you move?
X.
Which one? The x or the minus 2x?
No, minus 2.
Yeah, that's what I would move. How?
Add.
Yeah, we're going to add that 2x, right? So what is 1x plus 2x? So 3x, and then plus 1 drops down, equals 4 drops down. And these canceled, right? Now, let's get x alone. What's my first step? Subtract 1. What's 4 minus 1? So 3x equals 3. And then for the third straight time, x equals 1. Sorry. I made it a little too easy on us, didn't I? So x equals 1. So which one do y'all want to go back to, the black or the purple one? Which one looks easier to y'all? It doesn't matter, right? It would give me the same answer either one. And that's the point you need to know. So it's just preference. Like which one looks easier to you? Well, y'all all said the same one I did. This one. That one looks easier. Because it's just x plus 1, and what's x? 1. So 1 plus 1 equals?
2.
So my x value is? My x value is 1. And my y value is?
2.
So my solution is 1, 2. Okay? And that's it. That's how you do it. What do you think?
Too easy.
It's not too bad, is it?
Too easy.
Like you think it's too easy, like
Don't you ever say that again.
like you want me to make it harder?
Yeah.
Alright, let's go to the next problem. I only put this question there because you said that.
Yeah. Yeah. Yes.
I knew it was gonna happen. I'm that good at reading exactly what's gonna happen in the class every day before it happens.
Oh, why are you not the answer?
Well, good for you. Alright, here's the good thing about this problem. They're already both set equal to what? Alright, so I don't have to do that part. I can just set them equal to each other. And what's really the only reason this thing's hard for us?
Fractions.
And we love fractions, don't we? But listen, y'all got a calculator right in front of you that you can go second alpha y equals, sorry, wrong button. You can do alpha y equals number 1, and you can put any fraction in there you need. It's easy, okay? So don't let fractions be a cause of concern, please. It's okay. You can do this. All right, so let's do it. I'm going to move which one? You can move the 1 first if you want. So you can subtract 1. Again, you're going to come up with the same answer no matter what. He's got, so negative 2/3 x will equal 2/3 x. And what happens to 4 minus 1? Do you need something, pal? Okay, go to class. You need to be learning.
Derek,
What does that mean?
I heard your voice and I got the PTSD.
From having a whole year of dealing with me?
Oh yeah, that was awful.
Well, I had a little bit when I saw you walk by. So
What does that mean?
it's equal. Okay, so here we have 2/3 x plus 3 on the right side. So we're going to need to subtract it now to get x alone. So listen, don't stress about this. I know it looks ugly, but you can take your calculator, ready? Go alpha y equals number 1 and do negative 2/3. And then scroll over and put minus alpha y equals number 1, 2/3. So you have negative 2/3 minus 2/3 in your calculator, and you can push equals, and it calculates it just like it would if it was negative 5 minus 3.
2/3 is just 0.66, right?
It would be, yeah.
So we can just do that too.
You could, but I would really rather fractions when you're solving the problem, because then the reason here is that you're technically rounding 0.66 and you're rounding another 0.66. So when you double round, it's going to be really rounded. If that makes any sense.
Actually, I wouldn't have been 667.
Well, I mean, you really want to go there. But, all right, anyways. Negative 2/3 x minus 2/3 x. Did y'all get negative 4/3 x equals positive 3? What? Negative 4/3 x equals 3. Guys, fractions.
I've got a question.
Go.
So, instead of dividing negative 4/3 by 3, is there something else you can do?
Yes.
Or just give us the main problem fraction? Because I'm putting the calculator on that negative 9/4.
That's right. That's your answer.
Really?
Yeah. But there is another option. So, like he said, we're trying to get x alone, right? And negative 4/3 is being multiplied by it. So he typed into his calculator 3 divided by negative 4/3. Your calculator does all the work for you, and when he did that, he got negative 9/4, which is 100% correct answer. There is one other good option. You could multiply by the reciprocal. So you could also go 3 times negative 3/4. But guess what? Your answer's still what? It's still negative 9/4.
I got negative 4/9.
Yeah, I just.
Then you divided the wrong direction. You
Oh.
divided by 3
Yeah.
instead of dividing by negative 4/3. Since x is what we're trying to isolate, we've got to move the negative 4/3, not the 3. The 3 stays, and you're moving the other one towards it. And that's where the mix-up came. Okay? What is it?
It's just 2 1/4. Can we not do mixed numbers? Is that not a thing anymore?
No, you can. There's nothing wrong with mixed numbers, but there's also nothing wrong with improper fractions. They're not that hard.
Means it's wrong.
Definitely not wrong. What? That's not what improper means.
Pretty sure that's exactly what that means.
If you look up the definition of
I'm not being
improper.
stupid because I know I am, but
No, but if you look up the definition of improper, it doesn't mean wrong.
It means bright orange.
See? What? What does it mean?
Bright orange.
No.
Coming from emanating from the Inland Stadium. That's improper.
but you
Jabs.
promise something like you
Oh,
today.
yeah.
Gut shots. Yeah.
I'm in a mood to fight. Come on.
You know what?
Let's go.
That's a beautiful thing to hold. Okay? Alright. Now listen.
Uh,
We need to go plug this back into one of the equations. Which one is your preference? The bottom one?
Yeah, the bottom.
Either one is going to work fine. And you're just plugging it in. So if I went to the bottom one and went 2 over 3 times negative 9 over 4 plus 4, your calculator is going to do all the tallying for you, which I would encourage you not to have to do it in your head, and you're going to get what? 5 over 2, or 2.5. So your answer could be two things. It could be negative 9/4, 5/2, or it could be negative 2 1/4 and 2.5. I would absolutely take that. You know why? Because if you were to check your work and graph it, that would be your answer you would get. So nothing wrong with decimals, nothing wrong with mixed fractions, nothing wrong with improper fractions.
I've got the definition here.
What is that?
Not in accordance with accepted rules or standards. A fraction is not supposed to be that kind of fraction.
Stop. You are getting hung up on something not important. So, all right, let me show you guys one more thing. All right. So here we have a little word problem for a system of equations. Okay. And these can be difficult if you don't look at it for what it is. So I'm going to try to help y'all understand this, okay? It says the admission fee at a small fair is $1.50 for children, and it's $4 for adults. On a certain day, 2,200 people enter the fair, and $5,050 is collected. How many children, how many adults attend? Okay, so variables. I want you to think about variables. How many variables are here? How many different things are there? 2, right? So let's name them. The first one is kids, right? What do you want to call that? X. So let's say X is our kids, our children. And then we'll make our Y then what? Our adults. We had 2 things. But here's my next question. There's 2 equations I need to write here because there's 2 variables. If I have 2 variables, I need 2 equations to solve it. All right? So here's the thing. If there's 2 variables or 2 equations, that means there's 2 totals. Y'all see 2 totals in the equation? What's one of them? Huh? 2,200 is one of my totals. What total is that? How many people? Now, do you know how many kids came? No, but kids are represented by what? So I know that X kids came, right? Plus, do you know how many Y's came? But I know that if I took all the X's, all the kids, and all the Y's, all the adults, it added up to equal how many people? That's one of my equations. Y'all follow that equation? Now, what's my other total? The money, right? How much was collected? $5,050. So how do I write that equation? Okay, here's how. Do we know how many X's came in? But for every X that came in, how much did they collect from that X? They collected $1.50 per X. Right? Do we know how many Y's came in? But for every Y that came in, they collected how many dollars? $4 for every Y. And when they collected all the kids' money and they collected all the adults' money, how much did it all accumulate to equal? And that is my system of equations. Okay? So once we get here, what was our rules for today? Get Y alone. Okay? So look at this first equation. I'll do it in red. X plus Y equals 2200. How do we get X alone there? Or Y alone there?
Subtract X.
Subtract X. So Y will equal 2200 minus X. Right?
Yep.
Now let's do the other one, which is a little harder. It's a little more difficult, but we can do it. So I am going to first get rid of the 1.5x, right?
Yes.
So how do I get rid of the 1.5x?
Subtract.
I subtract 1.5x. So 4y will equal 5,050 minus 1.5x. And now what's the last thing I do here? We divide it all by 4. So listen, there's two really good options here. And I'm going to let y'all decide what to do. Do y'all want to go ahead and distribute that 4 to both of the things in the numerator? Or do y'all want to leave it like this to write your equations? Either one's fine. You call it. Go ahead and distribute. Okay, get your calculator then. And do, first of all, 50/50 divided by 4. 0.5? So 1,262.5. And then also do negative 1.5 divided by 4. Negative 1.5 divided by 4.
Negative point. If we round it to nearest tenth.
No, let's go ahead and use the whole number so our value will be correct. Since it's a terminating decimal, let's go ahead and use it. So negative 0.375x. Did y'all hear her question there? That's a good one for us to consider. I was just talking about rounding. If your decimal is a nice terminating decimal, go ahead and use the whole thing. Don't round it, okay? That way it'll ensure that your answer is right. So watch this. We now have y alone. So we can take 2200 minus x, right? That's this one. And we can set it equal to 1262.5 minus 0.375x. Is everybody with me so far right here? We got y alone, so they have to equal each other. I'm going to move this negative x, because that's a 1, and it's bigger than negative. It's a bigger negative, so it's a smaller number. So I'm going to add 1x. So 2200 will equal 1262.5, and then y'all help me out. Type in your calculator, negative 0.375 plus 1. Negative 0.375 plus 1. 0.625x. And now we're rolling. What do we do? Well, we can't add these.
Subtract.
We're going to subtract that 1262, right? So type in your calculator, 2200 minus 1262.5. 2200 minus 1262.5.
937.5.
937.5 is exactly right. And that equals 0.625x. Last step, and we're almost done with this problem. Last step. So what's 937.5 divided by 0.625? 1,500 what's? X's, right? X's were kids. So there was 1,500 kids. So how can I figure out how many adults there were?
Subtract it from 220.
Remember there was 2,200 total, right?
Yeah.
There's 700.
So there's 700 adults. So 1,500 kids, 700 adults. And that is how you do a system of equations word problem. Again, pretty challenging, but you guys can do this, okay? Y'all only have one of those to attempt in your assignment. Your assignment's below. Read the instructions, because a couple of them, they want you to use your calculator, and I would encourage you, you got some time, go ahead and do the ones that say use your calculator, okay? I think that's number 5 and 6. Go ahead and knock those out. Go ahead and knock those out, and then you can do the rest of them algebraically, okay? All right, so 9 problems. Any questions? Stop this recording.